Hi, hello students. In this video, I am going to show you how to draw ray diagrams effectively. So, you will have two kinds of mirror. One is concave mirror and the second one is convex mirror. For concave mirror, you will have six positions. They are, and in case of a concave mirror, the bulged surface will be inverted. And don't forget to draw painting while painting the mirror. The first position is object is placed at infinity, and the second position is object is placed beyond C, and the third position is object is placed on C. Coming to the fourth position, object is placed between focus and center of curvature. Fifth position, the object is placed on F, and the last position is between pole and focus. The first position of the object is at infinity. Second position beyond C. The third position is on C. Fourth position is between F and C. Fifth position of the object is on F. And the sixth position of the object is between focus and pole. Now the first position of the object is object is placed at infinity. Object is placed at infinity. We know that when the rays are coming from the infinity, all the rays will be parallel to each other. Here I will consider in the first diagram, I will consider all the rays are parallel to each other. Pole, focus and center of curvature. Here my condition is all the rays are parallel to the principal axis. This is one incident ray, second incident ray, third incident ray and fourth incident ray. And we know the rule, when the light rays are parallel to the principal axis, after striking a concave surface, they will pass through focus. So you will get the reflected rays, and moreover, they are converging on focus. So a concave mirror is a converging mirror, can be tell by this ray diagram. If you consider the rays, all the rays are meeting on focus. Coming to the image characteristics, image is formed on focus, and since it is formed outside the mirror, so it is a real image. And moreover, here you consider the image is a sharp pointed image. It is a sharp pointed image. Now in the second condition, I will consider that all the rays are not parallel to the principal axis. I will consider all the rays are making some angle with the principal axis. However, all the incident rays are parallel to each other. Pole, focus and the center of curvature. And while drawing this condition, you need to take the help of the principal axis. This is the focal axis, not principal axis. Now take the rays, they are making some angle. They are making some angle with the pole. However, they are parallel to each other. So these are all my incident rays, and here I am going to be apply the law, and this is the angle of incidence. We know angle of incidence will be is equal to angle of reflection in case of the spherical mirror also. So you will get the reflected ray like this. And from this diagram, it is clear that a concave mirror is acting like the converging mirror when the rays are fall on it. So whenever the rays are fall on it, since these are all parallel rays, definitely it will converge on focal axis. So like this you will get the rays. So here also you will get the same application of the image, and mainly this kind of application is used in making of solar cooker. Clear? So, and coming to the second position, the second position is object is placed object is placed beyond C. Object is placed beyond C. Pole of the concave mirror, focus of the concave mirror, and center of curvature of the concave mirror. Now I took the object O dash. So here I am going to be take any two rays. By means of that I will get the image characteristics. And the first rule is the ray is passing parallel to the principal axis. We know the ray is which is passing parallel to the principal axis. After reflection, it will be passes through focus. This is my reflected ray. And the second rule, the ray which is passing through focus after reflection, it will be parallel to the principal axis. Now, so the O dash point is formed here. Let us consider the intersection of the reflected rays is I dash. So you will get the image on I dash, since you will get the linear magnification. So I dash will be like this. So where O dash is object and I dash is image. Now if you consider the height of the object with respect to the height of the image, height of the object is more than that of the height of the image. And the first thing is the image is formed between F and C. The second thing is, since it is formed outside the mirror, so it is a real image, and the top of the object will be appear like bottom, and the bottom of the object will be appear like top. So it is the inverted image. Next, it is also a diminished image. So these are all the image characteristics when you place the object beyond C. And coming to the third position, what is the third position of the object? Object is placed on C. See children, here I am going to be apply the small logic. Carefully listen. Pole. Afterwards I will arrange focus and center of curvature. So that is the logic which I am going to be apply here to draw the ray diagram. And one more thing, when you place the object is on C, you will get the image also formed on C. Image formed on C. To save the time purpose, I am telling this kind of logic. Clear children? So in the examination you won't get much more time to draw the ray diagram. So whenever you got the question in the examination, please try to draw as early as possible and save the time. So when you place the object on C, you will get the image also on C, and it is a real image, and moreover always a real image is inverted. And coming to the height of the object will be is equal to height of the image. Now initially I will take the object o dash is the object. Since you will get the real image, inverted image, same heighted image, and moreover the image is also formed on C. So I will draw the image also, bottom side of the object. Let us consider that as I dash. Height of the object will be is equal to height of the image. This thing I explained. Now take a ray which is passing parallel to the principal axis. After reflection it will passes through focus. So this is our focus. Now take the second ray which is passing through focus from the top of the object. Now connect the point X and I dash so that you will get the image diagram clearly. And don't forget to represent the ray direction. This is the technique to draw the ray diagram when the object is placed on C in front of a concave mirror. And coming to the fourth position, object is placed between F and C. Now I have taken a concave mirror. Here also I am going to be tell you one logic to get the ray diagram simply. Pole, focus. Now take the object between F and C. Let us name that object as O dash. And coming to the rays, I am going to be take the incident ray which is passing parallel to the principal axis. After reflection it will passes through focus. Now take the second ray from the tip of the object. It should be touch as much of as bottom of the mirror lies below the principal axis. Now you will get the ray parallel to the principal axis like this. Now where will you get the image beyond C. See, look at here. See, if you take the aperture of the concave mirror is more, then the position will be here, nothing but more than this point. So whenever you are drawing the ray diagram, you should take the second incident ray which touches the extreme end of the concave mirror which lies below the principal axis. Now if you consider the image characteristics, where the image is formed, image is formed beyond C, and since it formed outside the mirror, so it is a real and inverted image. Next, and coming to the last characteristics, if you consider the height of the object with height of the image is more than the height of the object, so it is a enlarged image. Now coming to the fifth position. Now the fifth position of the object is placed on F, and this is also very important diagram. Now you place the object on F, pull, focus, center of curvature. Look at here, children. You should take the object on F. This is the object. The first O dash, let us name it as O dash. Now the ray which is passing parallel to the principal axis, it will be passes through focus. It is the first reflected ray. Now I am going to take the second reflected ray, which is passing in the direction of the center of curvature. So this is the ray which is passing in the direction of the center of curvature. So the ray which is passing in the direction of the center of curvature, after reflection, it will be passes through center of curvature and nothing but the ray which is passing through center after reflection, it will retraces its actual path. So if you consider these two rays which are reflected from the tip of the object, they are parallel to each other. Here our assumption is to be if the rays are parallel to each other, incident rays are parallel to each other, then they will coming from the infinity. In the similar way, if you are sending the parallel beam of light, our assumption is to be they will converge at infinity. At the infinite point, they are going to be converged. So by means of that, you will get the image will be formed on infinity. So where will you get the image? Our assumption is to be image is formed at infinity. I hope all of you understood why you had taken the conclusion of the image is formed at infinity. See, if you had taken the incident rays are parallel, there should be we should assume that there should be a source which is at infinity. If you are sending the parallel beam of light, then our assumption is to be they will converge on infinity. So the image is formed at infinity. And one more thing, since if you are observe the previous slide, since it's beyond, the image is beyond C, so at this condition the height of the image is more than the height of the object since it enlarged. If you consider at this condition also, the image is highly enlarged. Why? Because see, let us say this is the infinite point. If you have drawn the image, so this much of enlargement will be there. So that's why I consider the object image is highly enlarged image. I hope you why I consider these 2 points. I hope you understand why I had considered these 2 points. And however, it is from outside the mirror only, so it is the real and inverted. Next, the last one is for the concave mirror. What is the position? Object is placed between pole and focus. This one also very important, children. Many students are drawing wrong ray diagram. So take the concave mirror, represent pole, reflecting portion, focus and center of curvature. Now take the object between focus and center of curvature. Now take the first incident ray, which I am representing with blue sketch. The ray which is passing parallel to the principal axis after reflection, it will be passing through focus. This is my first ray. And the second condition, I am going to be take the ray which is passing through center of curvature. So this is the ray which is passing through center of curvature after reflection. After reflection, what will happen? It will retraces its actual path or reflects in opposite direction. Once again I am drawing, children, listen carefully. The first thing is the ray which is passing parallel to the principal axis after reflection, it will passes through focus. This is the first ray. That ray will be passes through focus. And coming to the second thing, I am taking the ray which is passing through center of curvature. After reflection, it will retraces its actual path. So this is the incident ray which is passing through center of curvature. After reflection, it will retraces its actual path. After reflection, it will retraces its actual path. And if you consider these two reflected rays, they will be like the diverging rays. Diverging rays. Now, so they never be intersect together. So what should you do? You should take the controlled rays. How will you get the control rays? So control rays are nothing but control rays. Control rays are nothing but the rays which are obtained by extending reflected rays in opposite direction. So now I am going to be extend the reflected rays in opposite direction. So these are all the dotted lines. Once again I am representing. So these are all my control rays. So now you got the point of intersection here. So you got the image which is formed inside the mirror. Coming to the image characteristics. What are the image characteristics? Image is formed. Where the image is formed? Image is formed inside the mirror. Image is formed inside the mirror, and the image which is formed due to the intersection of the control rays or which is formed inside the mirror, that is called a virtual image. Virtual image. If you consider top of the object, top will be become like the top of the image, and bottom will be become like bottom of the object will become like bottom of the image. So it will be the nature of erected image. It will be the nature of erected image. And if you consider the height of the image, it will be enlarged image. Now the second thing is ray diagrams for concave mirrors. Ray diagrams for already completed concave mirror. Second thing is ray diagrams for convex mirror. For convex mirror, you will have only two positions, and you know that for the convex mirror, the bulged surface will be outwarded, pole, focus, and center of curvature. Is it clear? And the first one is object is placed at infinity. Second one is the object is placed in front of the mirror. See, anywhere in front of it you can take, it will be considered as the in front of the mirror. Why? Because for all the positions of the object you will get same image characteristics. So the first position is, what is the first position? Object is at infinity. Coming to the second position, object is placed in front of the mirror. Object is placed in front of mirror. Here you will get only two positions. Why? Because the pole of the mirror and center of curvature of the mirror will be lies inside. So it is not possible to place the object inside. Clear? So if you place the object anywhere in front of the mirror, you will get the similar characteristics. That's why we will consider only two positions. What is the first position of the object in front of the, what is the first position of the object? The first position of the object is at infinity. So when you place the object is at infinity, here our assumption is to be all the rays will be parallel to the principal axis. First assumption. If not, I will draw the another diagram. Clear? So now I am representing the incident rays which are passing parallel to the principal axis. So these are all my incident rays, and you know the rules. any ray which is passing parallel to the principal axis after striking the convex surface, it will be diverges through focus. Carefully draw. You should connect the incident ray as well as focus, then draw the reflected ray. So here also you got the ray, you got the image which is formed due to the control rays only. Why? Because these dotted lines are control rays only. So it is also a virtual image where the image is from inside the mirror on F. Image is from on F. What is the position of the image? Image is formed on F, and moreover it is a virtual image and a sharp pointed image. Clear, children? Next, see, if the rays are not parallel to the principal axis, how will you get? So this is focus, center of curvature. These two are my incident rays. Now how will you get? And here I will make the assumption it is the angle of incidence. How will you get the angle of reflection? You will get the angle of reflection which will be is equal to I. Now you should take the help of the focal axis. This is the focal axis. Since here I forgot to tell the one point, a convex mirror is acting like a diverging mirror. Clear? And all the rays are diverging from focus. Here also the rays will be diverges from focal axis. Now to get the diverging point, I am extending this incident ray which is making some angle with pole. To that I had extended the control ray. Next, from that point I am connecting the next incident ray. This will be the reflected ray. Like this you will get the rays. You will get the image at this point I dash. I hope you all of you understood. And the last one, what is the last one? Object is placed in front of a convex mirror. So this is my convex mirror. Pole, focus, center of curvature. You should take any two rays. So let us take the object as O dash. Now take two rays, any two rays from the tip of the object to understand the image formation. Ray which is passing parallel to the principal axis. After reflection, it will diverges through focus. It will be diverges through. Wait a second, I will draw neatly. It will diverges through focus. This is my reflected ray. Now, for the better understanding purpose, I will take the incident ray which is passing through optic center. Optic center is nothing but center of curvature. The ray which is passing through center of in the direction of the center of curvature, after reflection, it will retraces its actual path. In the opposite direction, you will get the reflected ray. See, if you consider these two dotted lines are representing control rays only. And this is the first reflected ray and this one is the second reflected ray. And if you observe these two reflected rays, these are all the diverging rays. So whenever you are getting the diverging rays, you need to draw the control rays to get the image. Anyhow, I already had drawn the control rays. So you will get the image I dash inside the mirror. So what is the position of the object? What is the position of the object? Image is formed inside the mirror and it is formed due to the intersection of the control rays. So it is a virtual image. And the second thing, the top of the object will become like the top of the image, and bottom of the object will like the bottom of the image. So it will be erected image. And if you consider the height of the object with the height of the image is less than the height of the object, so it is a diminished image. Now try this thing. Look at the children, look at here children. I had taken a concave mirror, represented focus, pole as well as center of curvature. Try to draw two images. This is the first object position and this is the second object position. Had taken the same objects. First draw the image for the first object, and then after you can draw the image for the second object. You will come to know one beautiful observation. So please comment in the inbox after getting this observation. Is it clear children? And the final conclusion is I am plotting the graph for the concave mirror. So here I am not representing the virtual image nature, only the real image nature I am representing. No problem, you can represent. Now the first thing, between F and C, where will you get the image? That will be inside the mirror. Now this is F and P, not F and C. Now on F, where will you get the image? When you place the object on F, you will get the image at infinity. So on x-axis I am taking position of object, on y-axis I am taking position of image. Now the second position of the image is after F, between F and C. When you place the object between F and C, you will get the image beyond C. You will get the image beyond C. Now the third position is, now the next position is on C. When you place the object on C, you will get the image also on C. Next, after on C, the next position is beyond C. Where will you get the image? Now you will get between F and C. So I hope all of you understood. When you place the object between focus and pole, you will get the virtual image. It will be the virtual image. When you place the object on F, you will get the image at infinity. When you place the object between F and C, you will get the image beyond C. You will get the on C. When you place the object on C, you will get the image also on C. When you place object beyond C, you will get between F and C. And one more important conclusion you should observe here. When the object is moving from infinity towards the mirror, so when you place the object at infinity, you will get the sharp pointed image. Beyond C, you will get between F and C. On C, you will get same height. Between F and C, you will get same height. Between F and C, the image nature, height of the image will be enlarged. On F, you will get highly enlarged image. So whenever you are moving from infinity towards the mirror, the height of the image will be increases. Is it clear? And whenever you, one more important conclusion, whenever you are moving towards the mirror, the object distance will be decreased and the image distance will be increases. up to the point F. Is it clear? And when you place the object between pole and focus, you will get the virtual image. So, and one more conclusion thing, the next question is, the question is, a concave mirror will behave like a diverging mirror? Does a concave mirror will behave like the diverging mirror? This is the question, children. I hope you understand. Does a concave mirror will behave like a diverging mirror? Try to answer this question also. This is the second question. Already I gave the first question to observe the image characteristics when you place the object in front of the mirror. There I gave you two objects. So try to draw two images in the same diagram. Then you will get the important conclusions. And thank you for watching my video. If you like my teaching, please subscribe my channel and share to your friends. Thank you.